Additive manufacturing enables us to solve problems organically that we wouldn't normally be able to solve. So for example, we had a snowshoe clip on one of our mountain warfare training centers snowshoes that they always break, and they always need some sort of replacement. And the way they currently replace them, they use baling wire or tape. And so they emailed me the actual picture of the one that breaks, and of that we were able to reverse engineer it, run it through a finite element analysis, and actually send them a file. They had a 3D printer to start printing out these better snowshoe clips. So now their snowshoe clips don't break. So that's an example of that in-field innovation, also tied back to the digital thread with the engineers. So we had Marines on the USS Wasp. They brought their own 3D printer with them, and they said that we need this little plastic block to go on an F-35 Joint Strike Fighter to keep the landing gear door from rattling. Now, if we were to order that through the parts procurement process, it would be a $70,000 part, and we'd have to wait about a month to get it shipped out into the middle of the ocean to then get this Joint Strike Fighter to be able to fly again. But through our Navy Air Systems Command, we were able to get that part approved. Marines printed it on the ship, put it on the Joint Strike Fighter, and then got it up in the air. So that's a real high impact solution to a Marine Corps problem. So metal additive manufacturing enables a design space we haven't seen before. So we make tanks the way we make them because that's the only way we've known how to make them, is big, heavy metal things that are welded together. Now with additive manufacturing, we can start designing parts and pieces that don't look like traditionally manufactured parts, but are now up to 70% lighter. Now our tanks are faster, and now the fuel that we need to sustain operations, whether that's helping someone out in a humanitarian aid and disaster relief mission or going into full-scale combat, we don't need to bring as much with us. We're more efficient as a fighting force. So there's some statistic that in Afghanistan and Iraq, every 10 convoys, you'd expect to lose one person. And so every convoy is usually water or fuel. So everyone we can start getting off the road, we literally start saving lives. So that's where I see that design optimization really affecting Marine Corps operations. We're going to be able to fix more things faster and with greater efficiency, closer to the point of need. So we really call it tactical manufacturing and innovating at the edge of battle.